Welcome back to the deep dive. So, if you're someone who thinks artificial intelligence is still, tucked away in a lab somewhere, or maybe just something you see in sci-fi movies, you really need to think again. It is actively, and I'd say aggressively, reshaping our world right now. A lot of the time, it's working behind the scenes in ways that are, well, they're both miraculous and, at the same time, profoundly challenging to govern.
It really is the definition of a dual reality, isn't it? And that duality is exactly why this deep dive is so essential for you right now. We're seeing these technological breakthroughs, especially in really high-stakes fields like medicine, that were, literally unimaginable just a decade ago. But at the same time, we're grappling with these huge foundational questions, urgent questions. How do we establish ethics, governance, and crucially, who is accountable for these systems when they move out of the lab and, say, into a patient's room?
Okay, let's unpack that. Our mission here for you is to basically give you a shortcut to getting up to speed on this. We've been handed this digest of recent AI developments, and they focus on two critical and very interconnected areas. First, these radical, life-saving advancements happening in healthcare, and second, this urgent, simultaneous push for global ethical governance. We need to understand the latest win-win innovations, the undeniable progress, but also the critical policy shifts that are happening at the same time to keep all that progress safe and fair and trustworthy.
That's it. The conversation has fundamentally shifted. We're not really asking what can AI do anymore. The answer to that is clearly a lot and really, really fast. Now the conversation has pivoted. It's moved to the more complex, more profound question of how should AI be governed and who holds the power? And that's the core paradox of this moment, isn't it? Astonishing transformative potential, balanced by the absolute necessity of trust and effective ethics. The tech capability is just racing ahead of our social and legal capability.
And we have to hold that tension in our minds as we look at these stories, because the stakes just couldn't be higher, particularly when we start talking about medicine. So we're starting there, with where AI is quite literally saving lives. The speed and the impact here are truly phenomenal. We're seeing things move from a theoretical model to real-world deployment in weeks, not years.
It's the clearest, most urgent example of AI delivering tangible, immediate human benefit. So let's start with a condition that really highlights the best of what machine learning can do when, our own human cognitive capacity just hits its limits.
Right. Let's start with sepsis. For anyone who hasn't encountered it, sepsis is, it's a life-threatening condition. It's caused by the body's response to an infection. It could be pneumonia, a UTI.
Or even a dental abscess, something that seems minor. It's what happens when your body basically overreacts to that infection. The immune system goes into this overdrive mode that ends up damaging your own tissues and organs. The global mortality rate is just staggering.
And that's the real difficulty, isn't it? Sepsis is notoriously hard to detect early on. Its initial symptoms, fever, high heart rate, confusion, they're vague. They can mimic so many other less serious conditions.
And time is the enemy here. We know that every single hour of delay in getting the right antibiotics and treatment, it dramatically increases the mortality risk, sometimes by as much as 8% per hour.
Doctors are skilled, obviously, but they're human. They're trained to look for specific signs, changes in vitals, lab results, but those changes can be subtle. They're not always linear, and they can get lost in the sheer cognitive load a doctor has when they're managing, multiple complex patients at once. And that leads to delayed treatment, which, as you said, is often fatal.
Which is precisely why this new AI tool is such a monumental step forward. And this isn't some distant lab experiment. This is a system that was built to tackle a real immediate killer. Researchers just unveiled this new AI-powered predictive tool, and it's designed specifically for hospital use. Its function is crucial. It analyzes vast amounts of patient data in real time to predict when the condition is about to start.
Okay, let's get a bit more granular here. When you say vast amounts of data, what are we actually talking about? Because just saying EHR data is a little too vague for our deep dive audience. What specific data inputs give this AI the edge over a doctor's intuition?
That's a great question, and it really gets to the technical depth of this breakthrough. This isn't just a simple model looking at 2 or 3 variables. This is reportedly a deep neural network, and it's processing these granular, high-frequency data streams. So data that's streaming continuously and might be too noisy for a human to really monitor effectively. This includes minute-by-minute vital signs like heart rate variability, which is often a really subtle early indicator of systemic stress. It's also looking at respiratory rate trends, subtle shifts in blood pressure, continuous glucose monitoring data, even the rate of urine output over short intervals.
So it's not just looking at a snapshot of the patient when a nurse does their rounds every 4 hours. It's synthesizing a continuous feed of, what, millions of data points for each patient every day? A human doctor just cannot possibly process that volume of data
Yeah.
that quickly and, that comprehensively.
Exactly. The AI can spot those micropatterns, those tiny, often nonlinear shifts in the data landscape that happen right before a clinical decline. So, for example, a small, continuous drop in heart rate variability combined with a slight elevation in the respiratory rate and maybe a subtle deceleration in a patient's historical lactate trend. Those three data points, taken together, might only rate a 2 on a standard human early warning score, barely a blip. But the AI recognizes that specific combination as an imminent sepsis event with, say, 90% confidence.
And that brings us to the key phrase they used in the source material, remarkable accuracy. This suggests the model is just blowing past the standard scoring systems. So give us a real metric of its impact. What are the hospitals that used it reporting?
The reports from the pilot phases are transformative. This level of early warning is giving healthcare professionals alerts potentially 4, 6, even 8 hours before the traditional indicators would raise a major alarm. And the immediate, tangible benefit is measurable. Hospitals that implemented the system reported a verifiable reduction in sepsis mortality rates. We're seeing figures suggesting an 18% drop in mortality just during the pilot phases alone.
An 18% drop for a condition that kills millions of people globally. That is not just saving countless lives. That's a quantifiable, radical public health improvement.
And what's crucial is the dual benefit, that win-win we talked about at the start. When you prevent a patient from deteriorating to the point of needing, say, mechanical ventilation or organ support or dialysis, you are dramatically lowering the financial and resource burden on the entire system. You're optimizing how you use your resources. It shifts the whole dynamic from this high-cost reactive crisis management to proactive prevention and much simpler, cheaper intervention.
So the AI doesn't just save the life, it optimizes the budget, which means those resources can be redirected to other people who need them. That truly makes AI a game changer in emergency and critical care. It sets a powerful precedent for its diagnostic role.
Absolutely. And if sepsis detection is AI as a lightning-fast diagnostician, the next breakthrough shows AI as the ultimate surgical precision tool. We're moving from this generalized threat prediction to hyper-specific, personalized medicine.
And here's where it gets really interesting, moving into transforming oncology. We're shifting gears from a threat that affects many people to a therapeutic approach that's tailored precisely to one single individual.
This dives right into the unique genetic signature of the individual patient, and it addresses one of the biggest failures of current oncology.
Right. For decades, cancer treatment has operated on these population protocols, hasn't it? If you have lung cancer type A, you get treatment X. But as you just said, no two cancers are exactly alike. They're driven by unique mutations, and they're expressed differently within the host's specific immune system and genetic environment. So what's the innovation here?
Scientists have developed an advanced AI algorithm that tailors cancer treatments based on the patient's unique genetic makeup. And this involves processing some truly complex data. The algorithm doesn't just look at standard biomarker panels, it processes the patient's whole exome sequencing data. It's looking at millions of single nucleotide polymorphisms, SNPs, and the complex regulatory pathways of RNA expression.
That's a massive amount of data to input. So it's digesting the complete instruction manual of the patient and the complete instruction manual of the tumor at the same time.
Precisely. It's trying to understand the full complexity of what's called the mutation burden. For example, a key challenge in modern oncology is predicting resistance to immunotherapy. Those are the treatments that use the patient's own immune system. The AI can analyze the tumor mutation burden and the corresponding immunotherapy resistance markers, which are often just hidden in the massive noise of that exome data.
Wow. So if the AI can accurately predict that a highly toxic treatment is unlikely to work before the patient endures months of it changes everything.
It does. The algorithm aims to solve the twin problems of conventional oncology. First, to significantly enhance the efficacy of treatments hitting the exact target harder and more directly. It often does this by predicting optimal drug combinations that human doctors would struggle to calculate because of the combinatorial complexity.
And second, to minimize the side effects, which leads to a much more patient-friendly experience. If the AI can predict that drug B, which is known for causing severe neuropathy, won't work for this particular genetic profile, the doctor can just skip it entirely and pivot immediately to a less damaging, more targeted option.
The quality of life implication is huge. We're moving toward a future where a cancer diagnosis is immediately followed by a comprehensive genetic analysis that dictates a treatment plan. And it's a plan customized not just for the disease category, but for the individual molecular level interaction between the drug and the host.
That sounds absolutely incredible, but I do have to challenge this point a bit, especially since we're going to talk about equity and access later.
Yeah.
How scalable is this, really? Doesn't the massive genetic sequencing requirement just make existing healthcare inequalities even worse? I mean, only wealthy countries or specialized hospitals can afford whole exome sequencing and the computing power to run these algorithms.
That's a vital, critical point. Absolutely. The initial trials, of course, are often conducted in these well-funded academic medical centers, which limits the immediate scalability. However, the hope is that as sequencing costs continue to drop, and they have dropped dramatically over the last decade, and as the AI models become more efficient, the cost of the analysis will become negligible compared to the cost of ineffective traditional treatments. The economic argument for prevention and precision is often strong enough to drive widespread adoption, even in resource-constrained environments over time.
So the argument is that while the barrier to entry is high today, the cost savings from avoiding debilitating side effects and failed treatments will eventually make this the cheaper, more responsible choice globally.
Precisely. The success we're seeing in early trials is already driving massive investment. There's this growing optimism surrounding its potential to fundamentally transform oncology care, moving away from generalized toxic treatments to hyper-precision. This precision and speed is what makes AI such a disruptive force.
This technical capability is astonishing. But as we talked about right at the top, incredible power demands incredible responsibility. We've just covered life-saving innovation. Now we need to pivot to the equally critical side of the coin, governance. While AI is curing illnesses and solving complex medical riddles at this unprecedented rate, policymakers are, well, desperately trying to catch up.
And that gap between the technical capability and the regulatory frameworks, that's where all the risk lies. The power of these systems, whether they're deciding treatment protocols, influencing hiring decisions, or mediating social interactions, it necessitates a framework of control and trust that just did not exist a few years ago.
The contrast is striking. On one hand, you have the lightning-fast deployment of algorithms in hospitals. On the other, the slow, deliberate, multilateral pace of international policy. That tension is the subject of our next major development, this global push for a unified ethical framework.
Let's look at the policy side. The sources detail a major summit that was held this week in Geneva. And this wasn't some side event. It's important to emphasize the participants. We're talking leaders, ministers, and representatives from economic blocs and major world powers, all gathered specifically to address the ethical implications of AI technologies.
The location alone, Geneva, the hub for international diplomacy, human rights, global standards, that signals how serious this is. This is no longer seen as a niche tech issue that's confined to Silicon Valley. It's a matter of global stability, economic parity, and fundamental human rights.
The central theme and need was very clear, and it really centers on scale. The core concern is the increasing systemic influence of AI on critical areas like job markets, judicial processes, and social interactions. If an AI determines which candidates get an interview, or which communities get predictive policing, or which content is promoted to billions of users, that influence shapes society itself.
That's the definition of high stakes. When AI starts mediating economic opportunities and social interactions at a global level, we absolutely need guardrails for fairness and equity. If the algorithms running these systems embed bias, that bias doesn't just affect one person, it's replicated and amplified across billions instantly.
And this drives the central discussion theme. The need for international standards and regulations to ensure AI is used responsibly and equitably. The consensus among policymakers is that if we allow a patchwork of wildly different regulatory systems, or if some nations operate with no regulation at all, the technology will be deployed unevenly. This could create severe global inequalities, concentrate economic power in just a few tech hubs, or cause harm that crosses borders, like poorly regulated autonomous weapons systems.
It's a race against fragmentation. But how on earth do you get global consensus on something as nebulous as ethics? What specific ethical principles are they even trying to codify into this unified framework?
That's the hard part, and the sources indicate the debate was intense. The framework seems to center around three non-negotiable pillars of regulation. First, non-discrimination and fairness. This means requiring audits to prove that AI models don't perpetuate or amplify existing societal biases related to race, gender, or socioeconomic status. Second, human autonomy and oversight. This mandates that decisions with high consequences, like a medical diagnosis or a criminal sentence, must always have a human in the loop who maintains final authority and responsibility. And third, accountability and liability standards. If an AI system fails and causes damage, who is legally responsible? The programmer, the company that deployed it, the hospital that used it. The framework seeks clarity on that legal liability.
That third point, liability, that feels like a huge blocker. How do you harmonize the definition of accountability between, say, a common law jurisdiction and a civil law jurisdiction, especially when AI development is dominated by just a handful of nations?
That is where the geopolitical reality check comes in, and the challenge is immense. Achieving a truly unified framework requires consensus across fundamentally opposed legal and cultural priorities. For instance, some nations prioritize data sovereignty and restrict cross-border data flows rigidly, viewing data as a national asset. Other nations, often the ones with huge tech companies, advocate for open data sharing and minimal friction to spur innovation.
That sounds like a fundamental clash between protectionism and innovation. So how did the Geneva Summit manage to bridge that divide, even just in principle?
The outcome wasn't a finished legal document, but it was a crucial political commitment. The commitment from participating countries was to collaborate on creating this unified AI ethical framework. The key is the agreement on core principles. They're trying to establish a baseline. Regardless of your national laws on data privacy, you have to agree that an AI deployed in a hospital must be non-discriminatory. They recognize that if they don't agree on these fundamental rules, the powerful tech companies will just set the rules by default through their own platform policies.
So the goal is to prevent a future where the rulebook is written solely by the market forces of Silicon Valley or Shenzhen. It's a global attempt to reclaim regulatory authority over a technology that's rapidly decentralizing.
Exactly. It's a race to establish policy norms before the technology embeds itself too deeply to be governed effectively. And this brings us perfectly to the role of those powerful tech companies. Even as governments are struggling with this slow consensus-building process, there's enormous public and internal pressure to address issues of trust and transparency right now.
Right. Let's introduce the widespread public concern about biases and the opaque nature of machine learning models, the infamous black boxes. When an algorithm makes a decision that impacts your life, denying you credit, flagging a medical risk, or even prioritizing a treatment, you want to know why?
And that lack of explainability is a core technical challenge. Modern AI, particularly deep learning models, uses these incredibly complex architectures, millions of weighted connections and nodes, and they're often trained using methods like stochastic gradient descent. The resulting model can deliver incredible accuracy, as we saw with sepsis prediction, but the path it took to get to that decision is often impossible to trace, even for the engineers who designed it. That's the essence of the black box problem.
And that lack of explainability absolutely erodes trust, especially in a clinical setting. If an AI suggests a personalized oncology protocol, a doctor isn't just going to blindly follow it. They need some degree of mechanistic insight. They need confidence that the system isn't just, randomly guessing.
And this sets the context for the next piece of news. This voluntary and potentially industry-setting action taken by a major tech company. The sources detail an announcement. They've introduced a new initiative focusing on increased transparency in their AI models. This is a direct response to both the regulatory pressure coming from places like Geneva and that public skepticism.
This sounds like a massive concession, or at least a tactical shift. What exactly does this new tool do? How does it shine a light into that black box?
Specifically, the new tool is designed to provide detailed, high-level insights into how their AI systems make decisions. It doesn't publish the source code or reveal the exact weight of every single node, but it provides what's called feature importance scoring. For instance, if an AI decides a patient is at high risk for sepsis, the tool might articulate that 40% of the decision was weighted on the patient's respiratory rate trend, 30% on lactate levels, and 20% on heart rate variability.
So it's giving a human-readable receipt of the decision-making factors, even if the underlying mechanics are still really complex. This moves the conversation from, trust me, the algorithm works, to, here is why the algorithm made this recommendation.
That transparency is the key to building user confidence. Now, explaining motivations. First, it's clearly part of a broader and I think inevitable push for accountability in AI. By acting voluntarily, they get ahead of potential mandates coming from Geneva or national regulators. It positions them as industry leaders in responsible AI deployment.
But I have to remain a little skeptical here. How can we trust a voluntary tool from a company that has historically profited from the opacity of its systems? Is this genuinely about accountability, or is it more of a calculated PR move to gain a competitive advantage in securing high-value government and healthcare contracts?
It's likely both, and that tension is probably healthy. We should view this action critically. However, even if the motivation is purely commercial, the precedent is what matters. By opening the box, even partially, they hope to build trust with users and regulators. If you're denied a loan and the system can clearly show you that the major weighting was placed on your debt-to-income ratio, that's vastly more acceptable and actionable than just getting a blanket denial.
And crucially, it sets a new standard. This voluntary transparency measure puts immediate pressure on their competitors. If this tech giant is willing to explain their decisions in key areas, it becomes much harder for other players to maintain complete opacity, especially if they're also vying for those sensitive government or healthcare contracts where trust is absolutely paramount.
This signals that transparency is rapidly moving from an ethical nice-to-have to a critical competitive business advantage. You can't innovate safely in high-stakes fields like medicine without demonstrating that you're trustworthy. The governance framework, even in its nascent stage in Geneva, is already influencing corporate behavior.
That connection is fascinating. The policy framework is being built, but the marketplace is already enforcing a type of transparency requirement just to maintain public and professional trust. Okay, so we've covered these astounding breakthroughs in predicting sepsis and customizing cancer care, and then the vital regulatory steps with the Geneva Summit and corporate transparency initiatives. It's clear that AI is no longer a fringe technology. So, what does this all mean for the future of AI and how you interact with it as a patient, a consumer, or a citizen?
It means we're in an era of intense, dynamic interdependence. Let's revisit the connection between the two main themes. The speed of the technological advances, the ability to deploy an AI that saves lives by predicting sepsis. It puts intense, immediate pressure on regulators to act quickly and decisively. The more powerful and effective the tool, the more immediate the need for global governance and ethical clarity.
It's a powerful feedback loop, isn't it? Every medical triumph using AI is a proof point of its immense utility. But it simultaneously increases the public's dependence on that technology and therefore the risk if the underlying system goes wrong or operates unfairly. I mean, if we're going to rely on AI to guide oncology protocols, we must have systems in place mandated by Geneva-style agreements and supported by corporate transparency tools to verify that the model is fair and unbiased across different genetic profiles and demographics.
And that's the central pillar, trust. The successful deployment of AI, especially in sensitive areas like medicine, it hinges directly on public and professional trust. And this trust is only achievable through mechanisms like transparency and effective regulation. The Tech Company Initiative, which provides that feature importance scoring, directly supports the ethical deployment of the medical breakthroughs. If a doctor can explain to a patient why an AI recommended a specific treatment based on the transparency tool's output, they are far more likely to adopt that tool confidently.
It's a holistic ecosystem. You can't safely separate the tech from the policy. If the policies fail, the most effective technologies will eventually face backlash, mistrust, and maybe even societal rejection, regardless of their life-saving potential. We have to avoid a future where AI is viewed with suspicion just because its operations are kept secret.
The current landscape is defined by this transformative force, and its influence is total. The scope of AI's current influence is massive. It is shaping processes across various sectors, from immediate healthcare efficiency, the reduced costs and saved lives from sepsis detection, to establishing international policy norms for how we manage data and accountability in the future.
It's no longer about optimizing spreadsheets or minor processes. It's about optimizing human existence itself, whether that's through eliminating needless toxicity in cancer treatment or preempting a deadly medical crisis. But transformation, by definition, is disruptive, and that disruption requires us to think very carefully about who is in control.
Which brings us back to that central point from the source material. The importance of cultivating trust and ethics as these technologies advance. We have to match technical capability with social responsibility. The faster the technology goes, the harder we must push on the governance side to ensure it serves all of humanity, not just those who design it or those who can currently afford the most advanced sequencing technology.
That is a profound summary of where we stand today. We've seen undeniable proof of AI's power to save lives and transform daunting medical challenges into manageable ones. from the rapid real-time prediction of sepsis to the molecular-level customization of cancer care. We've also tracked the crucial groundwork being laid to ensure this technology is regulated globally and transparently. Thanks to the commitments made by world leaders in Geneva and the voluntary accountability actions being taken by major corporations. So let's do a quick review of the must-knows from this deep dive, the essential knowledge nuggets you need to take away. First, the incredible practical progress in health. Early sepsis detection using deep neural networks is processing these continuous high-frequency data streams, is providing critical early warnings, and demonstrably leading to saved lives and measurable cost savings in hospital systems. We saw reports of an 18% mortality drop.
Second, the future of treatment is personalized and molecular. We saw the development of personalized cancer treatment based on unique patient genetics. It's processing whole exome sequencing to predict drug efficacy and resistance, and it's promising enhanced effectiveness and significantly reduced side effects. This is truly the end of one-size-fits-all medicine.
Third, on the policy front, the global commitment to a unified AI ethical framework was solidified in Geneva. This is a necessary and daunting step to manage AI's rapidly increasing influence on jobs, justice, and social equity. It demands consensus on things like non-discrimination and liability standards.
And finally, corporate accountability is rising, driven by both public skepticism and competitive pressure. We detailed the corporate steps toward algorithmic transparency being taken by a major tech company. They're providing feature importance scoring to address that black box concern and to build essential trust with regulators and the public.
It's a monumental moment in time where capability meets critique. But we want to leave you with one final, provocative thought to mull over, one that connects all these threads of innovation and governance.
The tech company made its systems more understandable to build trust, recognizing that opacity is a fundamental barrier to widespread adoption in sensitive fields. Given that AI is being deployed globally, from hospital rooms guiding personalized treatment to international policy discussions about what is fair and just, this raises a crucial question for every citizen. Does the burden of understanding these complex algorithmic systems fall solely on the AI developers to make them transparent and explainable? Or must we, as users, as patients, as citizens, develop a baseline level of critical algorithmic literacy, an understanding of feature importance, data input quality, and algorithmic limitations, to truly hold these powerful systems accountable and participate meaningfully in their ongoing governance? Think about that tension between developer responsibility and citizen comprehension as these life-altering breakthroughs become commonplace in your daily life.